Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Oddly Dotted by Snepix, and here are the rules. Excuse me. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9 cell region contains the digits 1 through 9 exactly once each. Digits along the same red line are all the same parity, which is odd or even. Interesting. So this is a different type of parity line. Normally parity lines, you alternate parities. But in this puzzle, you specifically have all the digits on the same red line are the same parity. So keep that in mind. It's different from normal parity line rules. We have digits separated by a white dot are consecutive, and digits separated by a black dot are in a 1-to-2 ratio. That is, one is double the other. So as an example, say this was a 6 here, then this would have to be 5 or 7 to be consecutive with it. If this were 6 here, then this would have to be some combination of 2, 4, and 8 because they must be the same parity. But if we had a 2 here, then this would have to be 1 or 4 to maintain the 1-to-2 ratio between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so these are all the same parity. These are all the same parity. So that leaves, we have 4 odds and 4 evens in this box. That leaves 1 remaining odd digit in the box. For a complete set of the digits 1 through 9, if they're all consecutive, you have to have 1 be in a set of 3. So it has to be 1, 2, 3. And 9 be in a set of 3 that are consecutive, which makes that 9, 8, 7. So you're guaranteed the middle cells in this box have to be 2, 5, and 8, right? It's the same thing here. This must be 2, 5, and 8 here because 1 has to be next consecutive with a digit, and it has to be a set of 3 digits, so it must be 1, 2, 3. 9 has to be consecutive with a digit. It can only be consecutive with 8, so that forms a set of 9, 8, 7. So this cannot be 2, 5, or 8. So 1 and 9 can't be here. That means as consecutive digits, it can only be 3, 4, or 6, 7 here. We don't know which. Anytime you have 3 digits that are in a 1-to-2, or sorry, 1 digit that's in a 1-to-2 ratio with 2 other unique digits, it can only be 2 and 4, right? 2 can be in a 1-to-2 ratio with 1 and 4. 4 can be in a 1-to-2 ratio with 2 and 8, and there's no other digit that satisfies that. So this is 2 or 4, which is even. These digits are going to be, all of these digits are the same parity, and they are consecutive with this digit here, which means they must be opposite parities here. So we're going to make this yellow. Okay. This is consecutive with both of these. This is consecutive with both of these. Huh. What else do we have? So we have 2 evens and 2 odds here. These have to be opposite parities. So we're going to make this, I don't know. We'll make this dark and we'll make this medium. These have to be opposite parities. So we have 1 odd, 2 odds, 2 evens. So these are opposite parities. These form a set of 2 of each odd and even parity. These are opposite parities. That means we have 4 of each parity accounted for, which means this is odd. So all the rest of these are odd. Um, So this is 1379 here. 1379 there. This is 124 or 8. This is 124 or 8. This can never be 4. If this is 4, these are both even. And then these would have to be even, and we'd have 5 evens in this column, which is not allowed. So this must be 2, which means this is 2 or 8, and this cannot be 2 or 8. It's 1, 4 as a pair. So that eliminates 1 and 4 in the rest of the column. So the remaining digits are 3, 5, 6, 7, 8, 9. This obviously cannot be 5, 8 because of the 2, 5, 8 triplet in the row. These digits are consecutive. Cannot have 2. So 1 can't be here. Okay. 2 cannot be here or here or here. So 2 either has to be one of these two or here. Interesting. Hmm. This has to be 4 through 8 because you could have 3 through 9 on the outside. Two cannot appear here, so 2 has to be either here or here because this is odd. 5 and 8 could be here. This is 1, 2, 3, 4, 6, 8. I guess we could do that. This cannot, well, it could be 8, 4. Okay. These are consecutive. These are consecutive. We have 3 consecutive pairs. We know at least one of these is even, but that doesn't tell us very much. You could have an even here and then 2 evens there. Oh. 4 and 6 are next to 5 on this, in this box. But you can't have 4 and 6 be on the same side. So only one even digit is here. We have 3 odd digits here, which means this cannot be. This guarantees we have 2 odds here. So this is going to be 2 odds and 1 even, and this is 2 odds and 1 even. Because the 4 and the 6 have to be opposite, surrounding the 5 here. So they can't be in the same row. So that means we're guaranteed 5 odds already in row 9. These cannot be odds. These must be even. Since these two are even, you cannot have 3 evens here because that would be too many evens in the column 6 then. So this must be odd. So these are odd, which makes this 4 and is even. So this is 4, that's 1. No 6, 8 here. This cannot be 3, 5, 7, 9 here. It's 6 or 8. These are 3 odds, so this cannot be 3 odds here because that would be too many odds in the box. So this must be 3 evens. We are guaranteed 1 even here, and we can't have 3 and 4 here. So 1 even's guaranteed here, which means the rest of the column has to be odd. So then this is odd. This has to be even here. Because if these were even, you'd have 5 evens in that column, which is not allowed. And these are odd. So this is an odd digit, which means this is 1 or 3. This is odd then. These 3 have to be odd, which means these, again, have 2 odds and 1 even here. So the rest of the digits in the row are even. So since this is odd, this must be even here. No 4, 6 here. No 3, 7 here. This is 1 and 3, which is in a 1 to 2 ratio with 2 or 6 specifically. 2 cannot be here. We are guaranteed one of these is a 7, which eliminates 7 in the rest of the box. Because it's either 5, 6, 7 or 7, 8, 9. This cannot be 3, 5, 7, 9. It's 6, 8 as a pair, which eliminates 6, 8 in the rest of the box. This can't be 6. It's 2. These have to be both odd because we have 4 evens in the box. 2 is in a 1 to 2 ratio with 1. That leaves this as a 4. Where is 2 in row 9 then? Cannot be. Well, actually, this can't be 2, 5, or 8. Where are 2 and 8 in the box? It has to be here and here. So that's 2 and 8 there. Which means where are 2 and 8 in box 1? They have to be in these columns. So the dark must be even. So these are all even, which makes these are all odd. This is 2, 4, 6, and 8. This can't be 2 because of 2 in the row. No 4 here because of 4 in the row. No 2 or 8 here because of 2 or 8 in the column. So 5 cannot be either of these. So 5 has to be one of these two. We already knew that. This can't be 5. Where's 5 in box 8? It has to be here, which eliminates 5 in the rest of the column. So this is 7, 9 as a pair, which is consecutive with 8. That eliminates 7, 8, and 9 in the rest of the box and column. So as the last odd digit, this is 3, which eliminates, this can't be 3 or 6. So we have 7, 9 as a pair here. Remaining digits then in row 8 are 1, 4, and 6, which eliminates 1, 4, and 6 in the rest of the box. So no 1 here. This is 4. So that means 4 has to be here, which means it must be 4, 5, and 6, which means this can't be 6. That's 8. This is 6. Okay. This is 2, 4, and 6 here. Oops. Remaining digits of box 2 are 1, 3, 5, 6. 6 eliminates 6 as a possibility here. That's odd. Pink cannot be even, because if pink were even, we'd have too many evens in row 2. So pink must be odd, which makes yellow even. Since yellow is even, or sorry, yeah, this is 2 blues now. We are guaranteed a blue in here. So that's 3, and we're guaranteed a blue here to be in a 1-to-2 ratio, which means we have all blues accounted for. So this must be blue. This is red and red. So no 4 or 6 there. And one of these must be blue with a corresponding red. The only corresponding reds then are 1 with 2 or 3 with 6. So this is 1, 2, 3, or 6. The rest of the digits in the column are red. 2 cannot be here. This is a red-blue pair. Because this is red and blue as a pair, in box 3, we have all reds accounted for in row 1. This can't be red, it's blue, which means the remaining digits in the box are red. So this is 6, which means this can't be 6, that's 4. No 4 or 6 here, it's 2 or 8. No 6 here, it's 1, 3, or 5. So this is either, if it's 1, 2, 3, this is 1, that's 2, and that's 3. We are guaranteed 1 can't be here. So therefore 1 has to be here, which means the 3 has to be here. Which means this can't be 3, that's 7. So no 7 here. This can't be 3. So this is 5 or 9 here. And we have 3, 5, or 9 there. 5 cannot be here because of 5 in the row. So this is 3, 9 as a pair, which means this can't be 3 or 9. That leaves this as a 5. So the remaining digits in row 7 are 3, 4, and 9. This can't be 4, obviously. Remaining digits in row 9 are 1, 6, and 7. This can't be 6, obviously. If this were 2, 1, 3, that would eliminate all possibilities for this pair here. So this cannot be 2, 1, 3. It must be 8, 9, and 7. We have to have a 4 somewhere in column 7. It can't be here. It can't be any of the red cells. It can't be in the 1-to-2 ratio. So it has to be 4 there. No more 9 here. No more 8 here. Since this can't be 1, this cannot be 1, 2, 3 here. So no 2 there. 4 can't be here because of the 2, 6, 8 triplet. So this 2, 6, 8 triplet eliminates 2, 6, and 8 in the rest of the column. So this can't be 6. 6 can't be here, so 6 is guaranteed to be here, which means 6, 5, and 4 have to be here. This can't be 4, it's 1. This can't be 1 or 6, so that's 4, which makes that 6. No 7 here because of 7 in the column. Remaining digits in the column 2 are 1, 3, and 9. This is 1 and is odd. This must be even. These are the same color, or same parity. This is a different parity. We don't know which. This has to be 2 or 6. This is 6 or 8. 6 would be consecutive with 5 or 7. 8 would be consecutive with 7 or 9. So we're guaranteed one of these is 7. This can't be 7. This is 1. I don't know. Yeah. Consecutive digits here. No 1, 2, 3. No 2, 3, 4, because that would eliminate all possibilities for the cell. Okay, so remaining digits in column 7 have to be 1, 3, and 5. No 1 here because of 1 in the row. So this cannot be 1, 2, 3 because that would eliminate all possibilities for that cell there. Or this black crocky dot specifically. No 2, 3, 4, same reasoning. No 3, 4, 5 because it would eliminate all possibilities for that. So 4, 5, 6 does work. That would be 3 and 1, 2. So yeah. 4, 5, 4, 5, 6, 5, 6, 7 also works. 6, 7, 8 works, and 7, 8, 9 works. Interesting. Where is 1 in this box? 1 has to be either here or here. We don't know which. 2 cannot be here because if 2's here, where can 1 be? Can't be here because this requires 1 and 2 to be in a 1 and 2 ratio. But this could be 1, 3 through 9. So not too helpful. One of these is 2 or 8, and we also have 1, 3, 5, or 9. Okay. So this is either 4, 5, 6 or 7, 8, 9. If this is 4, 5, 6, where can 4, 5, and 6 be here? You can't have this be 3, 6, and then this be 4, 5, 6 here. Because only one of these could be 4, 5, 6 here. So if this is 4, 5, 6, 6, 4, or 5 has to be here. Which means 6 can't be here. So this would have to be 5, 6 guaranteed there, and you could have 4 there. Or this is 4, 5, 6, in which case 7, 8, or 9 is there. If this is 7, 8, or 9, you're guaranteed 7 or 8 there. That's interesting. If this is 4, 5, 6, that's too many cells in column 8 requiring 4 through 9. Right? These have to be 4 through 9. These have to be 4 through 9. If this is 4, 5, 6, that's obviously problematic. Because then you have 7 cells requiring the digits 4, 5, 6 in column 8. So therefore, this is 3, 2, 1. This is 4, 5, and 6, which eliminates 4, 5, 6 in the rest of the column. So this is 7, 8, 9 here. That's not going to be consecutive with 5 here, which means this can't be 4. Where is, this can't be 1, 2, or 3. Where is 4 in column 8? It has to be here. So this is 4, which eliminates 4, 5, 6 as a possibility here. This must be 8 with 7 and 9. So we have 8 with 7 and 9. These can't be 8 here. This must be 4 here with 1 or 3. And it can't be 1 because of 1 in the column. So this is 3 or 4. This is 1 and 6. 3 and 4 eliminate 3 and 9 there. 3 here. This is 9. That's 3. Which means these can't be 3. It's 1, 9 as a pair. That leaves the remaining digits as 3, 5, and 7 in the box. That eliminates 3, 5, 7 in the rest of the column. This can't be 7. That's 9, which makes this 7. So we have even. These are odd. This is even. So we have a guaranteed 7 here. So this cannot be 7. Where is... So one of these is 7. No 4, 5 here. No 5 here. Okay. So we're guaranteed a 7 here. We cannot have both 8 and 9 here. So this must be 7 and 8. So this is either 6, 7, 8 or 7, 8, 9. So this cannot be 8 or 9 here. Or sorry, it can't be 8 here. Technically, you could have 2, 1, 2, 3, no 4, 5, 6, no 7 or 8. So same with this. 1, 2, 3, no 9. So no 9, no 1. This is 2 or 3. 4 eliminates 4 here. This is 2 or 3. One of these is 2 or 3. That eliminates 2 and 3 in the rest of the box. So this can't be 2 or 3. It's 5, which means this can't be 5 here. So this is 1 or 9. We have a 7, 9, 7, 9 pair in row 3, which eliminates 7, 9 in the rest of the row. So no 9 here. It's 1, which makes that 9, which means this can't be 9. 1 eliminates 1 here. This can't be 7. Where's 1 in box 2? It must be here. So this is 1. Okay. This cannot be 6 here. So this is 7 or 8. This is odd. So it has to be 3, 5, or 7, but there's no 5 because of 5 in the column. Where is 5 in column 8? It has to be one of these two. Doesn't tell us much. Remaining digits in row 4 are 2, 3, and 6. This cannot be 2 or 6. So this must be 3, which makes that 2. This is not 1 and 2 as a 1-2 ratio. So this is 3, 6. 2 eliminates 2 here. So that's 6, which eliminates 6 in the rest of the box. 3 eliminates 3 here. So it's 5 and 3. 5 eliminates 5 here. So that's 3, which eliminates 3 there. No 3 here. So that's 1. This 6 eliminates 6 here. So that's 2. Which makes that 6, that makes that 8, that makes that 2. 8 eliminates 8 here, so it's 6, which is next to 5 and 7. So it's 5 and 7 there, which makes that 3. 5 eliminates 5 here, so it's 7 and 5. 7 eliminates 7 here, so it's 9 and 7. So no, this has to be an 8, 9 pair here. 7 eliminates 7 here. This cannot be 9 anymore because this has to be 7, 8, and 9. So this is 8 as an even digit. The oranges are red. So this is 8, which makes this 9. That's 7. This 1, which is an odd digit. This cannot be 1, 2, 3. So this is 6, 5, 4, which means these are even. This is odd. This is even. These are odd. So this is 5, 6, and 4, which eliminates 4 here. So that's 2 and 4. 5 eliminates 5 here. So it's 2, 1, and 3. This can't be 3, so that's 6 and 3. We have all evens there. This is even. This cannot be even because it's no 8 anymore. So that's odd. That's even. These are even. These are odd. This is 9. That's 8. 3 is odd. We need another even in row 6, so these two are odd. Okay, no 3 or 9, so this is 5, 7 as a pair. This can't be 5 because of 5 in the column, so that's 7. This is 8, that's 9, which makes that 7. No 3, 5, or 7 there. It's 9, which leaves that as a 5. Interesting. Yeah, these new types of parity lines is very interesting. I mean, we've done similar things, just never on a line per se. I don't think. We've had other rules which enforce parity in a certain way. But, yeah. That was interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.